So I was just reading about this new puzzle game called Pips from the New York Times. Have you heard of it?
Yeah, it's really interesting. The goal is to cover a shape made from square cells with dominoes, right?
Exactly, and it gets tricky because there are constraints, like the number of pips in a region must add up to a specific number.
Right, and they publish 3 puzzles daily: easy, medium, and hard. But I heard the hard ones can take quite a while to solve.
Yeah, for sure, some can take ages with brute force. That's why using clever algorithms is key to solving them.
Speaking of algorithms, I found out they use a backtracking method, which is like a structured trial and error, right?
Exactly, you place a domino, check if it's valid, and if not, you backtrack and try another spot.
That sounds efficient, but I wonder how they manage the increasing complexity as the board gets bigger.
Great point, the number of possible solutions increases rapidly. They actually use geometric info to guide their searches.
Wait, so they analyze the shape beforehand. That's smart. It reduces the configurations to check.
Right, they even prune the search tree to avoid dead ends, which speeds up the solving process significantly.
Pruning, how does that work exactly?
They check the constraints as they place each domino. If a placement doesn't work out, they move on immediately.
That makes sense. So they're not waiting until the end to validate the entire puzzle.
Exactly, plus, certain regions within the puzzle have specific rules, like equal regions need the same pip counts.
And for unequal regions, they must have different pip counts, right?
You've got it, it's fascinating how these constraints add layers of challenge to the gameplay.
But doesn't that also make the algorithm more complex? I mean, keeping track of all those conditions.
For sure, each type of constraint requires its validation logic, which adds to the algorithm's intricacies.
I guess that's why they chose F# for implementation. Functional programming fits well with these types of problems.
Exactly, F# handles state changes immutably, which is perfect for the precision needed in puzzle solving.
That also makes sense with how they define dominoes. Each has a pip count, and they don't assume 6 is the max.
Right and doubles are unique too, they only have one orientation which simplifies placement.
It's like a little twist in the rules to keep things interesting. How do they track empty spots on the board?
They use a special pip count like -1 to indicate empty cells, ensuring the board's immutability.
That's really clever. So everything is organized for efficient searching.
Exactly, and when they create the puzzle, all regions and constraints are part of the same type.
So it's like a living entity that evolves as you solve it. I love that interactivity.
Totally, the backtracking algorithm makes it possible to find solutions, and it's lazy too.
Lazy, how does that work? I'm curious.
Well, you can stop after finding the first solution instead of exhausting all possibilities.
That's a huge time saver. Do you think this approach could work for other puzzle types?
Definitely, the principles of backtracking and pruning can apply to a lot of different puzzles.
It's like a universal approach, but I wonder if there are scenarios where it might not be the best fit.
Good question, some puzzles may have more complex constraints that could slow down this method.
Or what if the puzzle is designed to have multiple solutions? That could complicate things.
Exactly, that's when the algorithm would really need to shine to efficiently explore those options.
I can see how challenging that would be. It makes the efficiency of the algorithm even more important.
For sure, but it's exciting to think about how these techniques can improve puzzle solving in general.
Totally. Makes me want to try solving some Pips puzzles myself.
You should, it's a fun way to apply all this algorithmic thinking. Plus, it's a great brain workout.
Sounds like a plan. I can't wait to dive into the logic behind it. Thanks for breaking it down.
No problem, I love discussing this stuff. Let's keep exploring more puzzles together.